The Rolls Royce jet engine, the pinnacle of engineering excellence. As pioneers of power, we are entering a new era, one where our engines and innovative care services are supercharged by advancements from the digital world. This is the era of the intelligent engine. The intelligent engine is connected with other engines, with its support ecosystem, with its airline, allowing us to sense and respond to changes in the operating environment. It's contextually aware. Big data means that it's aware of its current operating context and the requirements of its airline, offering advice to minimize fuel burn and operational risk. It's self-aware. It knows when it needs maintenance, and in the future, thanks to advanced robotics and artificial intelligence, may even be able to perform that maintenance itself, without any human interaction. And it learns. Through machine learning, it learns from its experiences and those of other engines in the fleet, identifying and fixing issues long before they have any impact on an airline's operation. All part of achieving our vision of ensuring every Rolls-Royce powered aircraft takes off and lands on time, every time, with maximum efficiency.
The intelligent engine isn't just a name, but an engine that connects the customer to Rolls-Royce seamlessly, whilst also connecting itself to the surrounding and delivering a disruption-free service.
R² Data Labs is a new venture within Rolls-Royce. It aims to be the data innovation hub, pushing for new technologies, new analytics. We're looking every day at machine learning techniques and advanced analytics to improve the way we understand and use data every day. It's essentially a safe space for everyone to come and try out new ideas, what they would like to do, and see where it goes from there.
The way we support Intelligent Engine today is we have a growing community of artificial intelligence experts and practitioners who are using data and finding value in a way we hadn't even dreamt of. We are developing and continuously improving our engine health monitoring system, and at the same time working with our customers to understand their experiences and how we could create the engine of tomorrow.
R² supports the intelligent engine by looking at everyday new technologies and applications for it. It's always looking at new data streams, possible ways to apply data that's outside of Rolls-Royce to help with the intelligent engine.
We are at the forefront of leading the artificial intelligence community in our sector. And with that, we'll learn some lessons, but also make great strides, taking the whole industry forward, and our customers will benefit from that. And finally, as a digital-first organization, R² is becoming ever more responsive to the changing needs of our customers in a fast-changing technology world.
It's almost as big a change as going from piston engines to gas turbines. This is once again an opportunity for Rolls-Royce to prove that we are pioneering the power that matters. What is the intelligent engine? It's our vision for the future, and it's a really exciting concept. The easiest way to think about it is to imagine three circles, that of the product, service and digital, and then progressively overlapping and coming together. So we've already got, to some degree, intelligent engines in the Trent family, and each Trent has become progressively more intelligent. But our vision and what we're really seeking to align everything we do to is where those three circles completely overlap, and it brings out a completely different set of value proposition for the customer. Once those three circles completely overlap, then you get an engine that is connected, it is contextually aware, and it is comprehending. And by that I mean it's connected to every other engine in the fleet, it's connected to the infrastructure, it's connected to the airline's infrastructure. It is contextually aware in that it knows exactly where it is and what it's been experiencing, whether that's weather, how the pilots use it, etc. And last but not least, it's comprehending. It can actually learn. Through artificial intelligence and machine learning, it can actually understand what it's thinking and feeling and act upon that to get the best end result for the customer. So the intelligent engine isn't a specific engine. It's a concept that's applicable to all of our engines, some retrospectively and certainly all going forward. Everything that we're seeking to do, whether it's a new technology that goes straight into the product, it's a new technology that enables us to deliver a better service, or it's something that allows us to actually design the product in creation of a digital twin, then it's in one of those three circles which are increasingly overlapping, and we will apply this concept to everything we do going forward. So what this means for our customers is that it allows us to meet what they need, and that is for every Rolls-Royce engine to take off on time, to land on time, and be as efficient as possible. Wherever we are in the company, we are pioneering activity to achieve this vision of creating the intelligent engine.
Volcanoes are pretty impressive things, naturally occurring events, and most people have seen some big dramatic pictures on the news. About 3 to 4 times a year there's a big eruption somewhere on the planet that can put volcanic ash well above 20,000 feet. And these are the volcanic eruptions that really cause problems for aviation, because you're going to cut across cruise pathways. Well, it can cause a multitude of problems, volcanic ash, when it goes into an engine. It can erode and wear away components at the front end of the engine, which is problematic, but when it really gets problematic is when it gets into the very hot sections of the engine, where the temperatures are so hot, the volcanic ash, which is a silicate particulate, starts to melt, and it will stick to components and build up a deposit. And as that deposit builds up, it reduces the flow through the engine. The problems that volcanic ash causes engines led to essentially a total avoidance strategy. There wasn't sufficient information available to define a safe allowable limit, so total avoidance was the strategy adopted. This was fine until a little-known volcano in Iceland called Eyjafjallajökull erupted in April 2010, sending an ash cloud over northwestern Europe, one of probably the busiest airspace in the world. As a result, people weren't flying. One of the big inputs we needed for the intelligent engine was engine health monitoring data, which we took from the availability centre. So they're collecting data all the time, and that's a great source of data on how engines are faring in the environment they're operating in. And you link that back to the models of what they're operating in, and it just keeps educating itself, more and more better data. So the engine health monitoring data becomes more intelligent as well. So we've started to work with the colleagues working on the intelligent engine, so that you can calculate through real time almost the damage you're accumulating. You have to collect data from that exposure and feed it back into the model. So the models become self-educating. It's essentially machine learning, but you're collecting huge amounts of data and building really increasingly sophisticated models that allow us to really deliver the concept of the intelligent engine. So by early 2017, May 2017, we were in a position to declare that the Rolls Royce engines, the Trents and RB211s, could tolerate up to 4 milligrams for an hour and concentrations similar to that. Our customers can use that information to maximise their use of the airspace rather than having to avoid it completely without any compromise on safety. The next thing that we're going to work with the operators is the impact on economic damage. So they know they're safe, but the next thing they need to know is how much impact on the engine performance are we going to incur. And this is again where the intelligent engine concept comes back in, because you can use that to model and accurately predict what their outcome will be. This is a great example of how we can make big data work. It's a great example of how we can collaborate with outside organisations and get that working for us, but it's a great example of how the intelligent engine is going to work too. The Civil Aviation Flight Safety Award is a huge honour for me personally, but also the team. And it's nice to get recognition for the 7 years of effort, really, and collaborating with people to be able to deliver something that's useful to aviation, and that to be recognised by such an important body as a contribution to flight safety.